Ammonia, also known as NH3, is a colorless gas with a pungent suffocating odor composed of nitrogen and 3 hydrogen atoms. It is a strong Lewis base due to the presence of a lone pair on the central nitrogen atom. It is produced naturally in the human body, in the environment, and is one of the most commonly produced industrial chemicals. The human body makes ammonia when the body breaks down foods containing protein into amino acids and ammonia, then converting the ammonia into urea. The ammonia molecule has a trigonal pyramidal shape as predicted by the Vesper theory, with an experimentally determined bond angle of 106.7 degrees because of distortion due to the presence of a lone pair on the central nitrogen atom, having sp3 hybridization. In pure form, it is known as anhydrous ammonia and is hygroscopic, that is, it readily absorbs moisture to form ammonium hydroxide, that is NH4OH, which is a caustic solution and a weak base, used as a cleaning agent and sanitizer in households and as industrial cleaners. Ammonium hydroxide is also used in the manufacture of products such as fertilizer, plastic, rayon, and rubber. Ammonia is easily made in the laboratory by heating an ammonium salt such as ammonium chloride and NH4Cl with a strong alkali such as sodium hydroxide or calcium hydroxide. And the reaction is 2NH4Cl plus CaOH whole twice gives us CaCl2 plus 2H2 and 2NH3, which is in gaseous form. Haber Bosch process is one of the most efficient and successful industrial procedures to be adopted for the production of ammonia, developed by the German physical chemist Fritz Haber, who later received the Nobel Prize for Chemistry in 1980, and later translated into a large-scale process using a catalyst and high-pressure methods by Haber Bosch, an industrial chemist who won a Nobel Prize in 1931. In this, the atmospheric nitrogen N2 is converted to ammonia NH3 by reacting it with hydrogen H2 in the ratio of 1:3. A catalyst which is actually slightly more complicated than pure iron and has potassium hydroxide added to it as a promoter to increase its efficiency is used. According to Le-Chatelain's principle, lower temperature around 400 to 450 degrees Celsius and a higher pressure 200 to 400 or higher atmospheres is favored, and thus the proportion of ammonia yielded in the mixture is more. The reaction is reversible and the production of ammonia is exothermic reaction. The reaction is N2 plus 3H2 gives us 2NH3 in gaseous form. About 80 to 90% of the ammonia produced by the industry is used in agriculture as fertilizer. Ammonia is also used as a refrigerant gas in air conditioning equipment for purification of water supplies and in the manufacture of plastics, explosives, textiles, pesticides, dyes, and other chemicals, in the waste and wastewater treatment, cold storage, rubber, pulp, and paper and food and beverage industries as a stabilizer, neutralizer, and a source of nitrogen. It is also used in the manufacture of pharmaceuticals. Ammonia should be handled with care, as it interacts immediately upon contact with available moisture in the skin, eyes, oral cavity, respiratory tract, and particularly mucous surfaces to form ammonium hydroxide, which causes the necrosis of tissues through disruption of cell membrane lipids, which is saponification, leading to cellular destruction. As cell proteins break down, water is extracted, resulting in an inflammatory response that causes further damage. If the chemical is on the skin or in the eyes, it is advised to flush with lots of water for at least 15 minutes. If the poisonous fumes are inhaled, the person is immediately moved to fresh air. And if the chemical was swallowed, the person is immediately given water or milk, unless the person is having symptoms such as vomiting, convulsions, or a decreased level of alertness that makes it hard to swallow.